Hello everyone and welcome back to another episode on complete reference to CUDA programming. So far we are familiar with now CUDA programming execution model. We are also a bit familiar with what's the difference between process and thread, and we are also familiar with the GPU architecture. Now from this episode onwards we can start exploring the new concept, that is thread organization in CUDA programming. To understand this concept, we'll take a simple computation here of vector addition. So here we are having a typical C programming for loop which is performing addition of two vectors. So here I am having array A and array B, and the results of this addition of array A and B is stored into the array C. Now this is a simple for loop ranging from 0 to n. So first we'll try to understand how sequentially that computation is performed on CPU side, and then we'll try to understand what if we have multiple threads, how we can execute this particular computation. So to demonstrate that, let's see this particular picture here. We are having vector A which is having 8 elements, vector B is also having 8 elements, and the values are initialized to 2. Now what we have to perform, addition of the corresponding elements of vector A and B will be stored into the vector C. Now if it is a sequential C program, then how it will get executed? So first it will start executing the iteration number 0. So when I equal to 0, it will perform addition of 0th element of A and B, and the results will be stored at 0th element location in vector C. Now once this operation is over, it will go to the next iteration, that is I equal to 1, and it will perform the addition of first element of A and B, and it will be stored into the first location in the C. So this will follow till the end of your loop. So this is called as sequential execution, because here we are not spawning multiple threads. But what if I can spawn, let's say, multiple threads? So in this case I am spawning, let's say, 8 threads. Now I have 8 threads that can execute in parallel. So in this case I can say, let's say this thread is going to perform addition of 0th element of A and B, and result will be stored in the 0th location in the vector C. Same way, if I take this thread number 4th thread here, so it will perform addition on 4th element of A and B, and it will be stored in the 4th location in the C. Now question is how to determine which thread is going to perform which particular addition or which particular location in that arrays. To do that, here I am giving a unique thread identification number for all these threads. So I am having 8 threads, and 8 threads are having their own IDs from 0 to 7. And based on their thread IDs, I am dividing the task among the multiple threads here. So multiple threads. Now question is it the same way we are going to follow the thread organization in CUDA programming? No, it is going to be slightly different. Here the threads are organized in little bit different fashion. So if I am having n number of elements in an array, so I cannot say simply n number of threads I am going to launch. Rather than they are having a special way to organize these threads is called as block and grid, right? So here the concept is very simple. So we are going to make a group of some threads, and we are going to call it as a thread block, and we are making group of such thread blocks, and we are going to call it as a grid. So you can see in this particular figure, so I am having these 4 threads are there, and they are grouped together to form a block here. Similarly, here I am having another group of threads, and that is going to form another block here, and group of such blocks I am going to refer it as a grid. But question is again how to identify these threads and block. So obviously the same way, if I am having thread IDs, I must have the block IDs also, right? So in addition to that, few more parameters are associated with every thread in CUDA programming. So let's try to explore one by one. So key takeaway from this particular slide is threads are grouped together to form thread block, and thread blocks are grouped together to form a grid. So these are the parameters associated with every thread. The first one is thread ID, and that is nothing but a unique thread number associated with every thread. But this is going to be the local to block. We'll see what do you mean by this local to block in a while. In addition to this thread ID, we'll also have block ID, right? That is going to be unique block number. Then we'll be having block dimension. This gives you total number of threads in the block. That means how many threads are grouped together to form a block. And grid dimension is another parameter associated with the thread, and that gives you total number of blocks in that grid. And that is going to be very, very crucial in order to distribute tasks among multiple threads. Now these are the parameters associated with the thread, but how to retrieve them? Now to retrieve them, we are going to use special variables here, and that are going to retrieve those IDs. For example, let's say I want to find out the ID of the thread. Then in that case, I'll just write in the GPU function thread idx.x, and I can store into a variable. Now this is going to return the ID of the corresponding thread. Now you can see here another important thing is something I am mentioning here .x, and that indicates in x dimension. So in CUDA programming, we can arrange threads in 1D, 2D and 3D form. That means I can have thread ID in x direction, y direction and z direction. But to keep it simple as of now, we'll say the threads can be organized only in x dimension, right? So this thread IDX is going to return the ID, but that is going to be local to the block. For example, you can see here in this block, we are having 4 threads and their IDs are 0, 1, 2, 3. Now in next block also I am having the same range of IDs 0, 1, 2, 3. That means if I call this thread idx.x, it will give me ID of the thread that is local to that block. That means you can see here this 0, 1, 2, 3 is local to this block and 0, 1, 2, 3 is local to this block. Now if this thread 0 execute this statement thread idx.x, then it will return the ID of this thread is 0. And the same ID will be written for this thread also. So if this thread 0 execute thread idx.x, then it will also return the same value, right? So this gives thread number local to the thread block. Now we have another parameter, that is block ID, and this gives block number. That means in which block thread belongs to, we can find out using this block idx.x. Now one thing you can notice here, both the thread IDs and block IDs are starting with index 0. So it is very important because typically in other programming we use index maybe starting with 1, but in C and CUDA programming we typically have indices for arrays as well as the threads that are starting with 0. So if you want to find out the ID of a block in which that thread belongs to, I can use block idx.x. Then if I want to find out total number of threads in a given block, for that I can use block dim.x. This will give me total number of threads per block. And you can observe here all the blocks are having same dimension in a grid. So we cannot have block 0 which is having 3 threads and block 1 is having, let's say, 4 threads in a grid. Inside a grid we'll be having all blocks are having same number of threads, and that can be retrieved using block dim.x. Similarly, I'll be having another parameter grid dim.x here, grid dim.x, which will give me how many blocks in total we have launched in this configuration. So in this case we are launching 2 blocks, so it will return 2. So for every thread we can retrieve these parameters. So what is its local thread ID, in which block it belongs to, what are the block dimension, that means how many threads per block, and how many blocks we have launched in total, that can be retrieved using this grid dim.x. So that's it for this introduction to thread organization. And obviously as of now it will looks little bit complicated, but later on when we talk about one simple example, that is hello GPU, where we'll try to understand by the thread organization by executing one program. So in next episode we'll take a simple program to understand all these concepts, and we'll try to retrieve all these IDs in that program.